Hello guys, welcome to the part 2 of our video of nature of roots. I hope you are still good, you have grasped. Now you know what are real numbers and rational numbers and irrational numbers. Okay, so if you want to find the roots of any given quadratic equation, we can use this formula to find any roots of any given equation. Okay, but if we want to know the nature of the roots, we're going to use basically this thing that is inside the square root. This inside the square root. This one is the one we call the delta. We can say also is called the discriminant. So basically, we are going to use the discriminant to determine the nature of the roots. So we're going to use the discriminant to determine the nature of the roots. Remember, we want to find out these roots, are they real or non-real? And or are they equal or not equal, or rational or irrational? That's what we need to find. So basically, now I'm going to show you how to use this delta in order for you to know whether these roots, the nature of this root. So I'm gonna wrap here, I'm gonna wrap everything here. Okay guys? Okay, so basically what we said, the nature of the roots, we said, we can start by saying that the nature of the roots must be real. When the nature of the roots must be real, it's when our delta is greater or equals to 0. So when you have an equation, when you have a given equation and your delta is greater or equals to 0, then you quickly know that the nature of the roots, they are real. Since I told you that when we say they are real, you need to know, because real numbers, we have rational numbers and irrational numbers. So your delta, if it's greater than 0 or equals to 0, you quickly know that they are real. But we know that our roots can be either rational or what? Or irrational. So we know that they can be either rational or irrational. So if these roots, they are, this delta is equals to a perfect square. Now we are talking about a perfect square, and it must not be equals to 0. If this delta is a perfect square and it's not equals to 0, what is a perfect square? A perfect square, we can say, is a number anywhere you can find its square root. That's a perfect square. For example, 9 is a perfect square. Because of the square root of 9, but again, what are our perfect square can be 1, they can be 4, can be 9, can be 16, and blah 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 blah. But also we can write them in alphabets. Sometimes when you're dealing with alphabets. For example, a squared. A squared is a perfect square because of when you square root a, what is the square root of a squared? It's a. So even 16p squared is still a perfect square because of we know the square root of 16, we know the square root of p squared. That's a perfect square. You also can have a minus 1 all squared, as long as anything that is raised to the power of 2, or it can be raised to the power of an even number. It can be raised to the power of an even number, then it's a perfect square. We can say that thing is a perfect square. A perfect square, as long as it is raised to the power of 2, you know that thing is a perfect square. Or if our delta, then if this thing is equals to a perfect square but not equals to 0, then we say this thing it's real, and then it's a what? It's a rational number. It's real and it's a rational number, the nature of roots. Ne? But if your delta, you find out that your delta is not a perfect square, is not perfect square, not perfect. If you find out that your delta is not a perfect square, if you find out your delta is not a perfect square, then it means this thing is real, but it's what? It's an irrational. So what are your irrational numbers? For example, when you get your delta as 10, 10 is an irrational number. 10 is an irrational number because when you find the square root of 10, you have to approximate it. You remember when I say irrational number, when you square root it, you have to what? You have to approximate it because of you can't really find it using your head. It's gonna crack your head. Everything that cracks your head, then you can. But if you know the exact, for this one, the square root of 1, the square root of 4, the square root of 9, the square root of 16, the square root of these things, you know them. But this one, the square root of 10, you don't know the square root of 10. Square root of 10, you have to approximate it. So that's why with a 10 is going to be a what? It's not a perfect square. Another thing that cannot be a perfect square is 2. We can have 2. When you find the square root of 2, you have to approximate it. Okay? And another one is when we have, for example, maybe 3p squared plus 1. If you find the square root of this thing, it's not going to give you anything. So this thing also is not a perfect square. Or the square root of 3q squared. You don't know the square root of everything like here. So this one makes it it's not a perfect square. So if your delta is not a perfect square, then it means it's an irrational. And then one last thing is either it can be rational or irrational, or the last thing can be what we can discuss here is either it can be rational or irrational. And then another thing that we can talk about is whether this thing if your delta is equals to 0. What happens if your delta is equals to 0? We said this thing is real. We said this thing is real, right? But if your delta is equals to 0, what happens if your delta is equals to 0? It means your roots are what? Are equal. Equal roots. So if your delta is equals to 0, your roots are what? We have equal roots. Ne? So for this one, what we're going to say, let me refresh with you a little bit. Ne? So if we find that our delta is greater than 0, and that number, that delta that we find is a perfect square, ne? It means the roots of these things, they are what? The roots of these things, they are real. It means they are real, rational, and what? Unequal. So, rational here, it means the roots are real, rational, and they are unequal. But if the delta is not equal to a perfect square, the roots are what? Are irrational, are real, okay, let's say they are real, irrational, and what? Unequal. But if our delta is equal to 0, it means our roots are what? They have equal roots. So it means we have what? We have equal roots. Okay? Yeah, that's what you need to. Okay, so let me just show you like the picture of how will this thing be seen when I sketch them on a graph. So I'm going to make a rough sketch of graphs so that we can see like when we say these roots are rational and everything like that, and equal roots and everything. So basically, okay, or I will discuss it on the next video. Thank you guys.